This video is to help you with section 2.3.4. We'll be using generic rectangles and factoring to apply the distributive property to multi-digit products. Because now that you've worked with generic rectangles, you've begun to see how useful they are for many problems that involve multiplication. Today you're going to look at how generic rectangles can be used to do mental math, and you'll discover a new mathematical property that you can use in many situations called the distributive property. So first of all, it says that Miranda likes the idea that she can do multiplication more easily by visualizing generic rectangles. She wants to rewrite 8 times 32 so she can easily find the product. Okay, so what you would be doing is thinking about how you would write a generic rectangle for 8 times 32. So you would start by deciding, do you want to have your 8 on one side on the top, or your 32 on the top? That's up to you. I'm just going to go ahead and go with 8 on the side and the 32 on the top. Okay, so that would be how you would set up your basic area model for generic rectangle. All right, then we would recognize that 8 times 30 is 240, that 8 times 2 is 16, and fill that in. Okay, then a number sentence that represents that would be that 8 times 32, and we can make that 30 plus 2 or 32, will equal 240 plus 16. Okay. And when you look at how that occurs, that is what we consider to be the idea of the distributive property. So what's happening is the 8 is being multiplied by 32, which we've broken into 30 plus 2. And then that means that you can take the 8 times 30 to get this result, this product, and then you can take the 8 times the 2 to get this product. All right. So that in a nutshell is the idea of the distributive property, that the number in front of the parentheses, again, there's no other operation, so we're multiplying, the number in front of the parentheses is going to be distributed to everything inside the parentheses. It's going to be multiplied by each of the values inside the parentheses. So the 8 gets distributed to the 30, 8 times 30 is 240. The 8 gets distributed to the 2, 8 times 2 is 16. Now, in terms of the answer, we know that that would give us, for part D, 256. But again, the idea here is really not about so much the answer, but about the process. That the generic rectangle is a way of seeing how we can break this apart, which allows us to then better understand the idea of the distributive property. So if we were going to look at some of these others, let's look at how we might do those. So for A, 5 times 628. Okay, so I'm going to put the 5 on the side. The 628, I'm going to break into 3 parts, of course, the hundreds, the tens, and the ones. So 600 plus 20 plus 8. And then the 5 times 600, well, 5 times 6 is 30. Adding the 2 zeros when you multiply gives you 3,000. A little messy, but hopefully you can read it. 5 times 20, 5 times 2 is 10, and then add the 0. And then the 5 times 8 is 40. Okay. So what the distributive property says is if you're trying to take that 5 times 628, if you didn't want to have to do, oops, my bad typing again. If you didn't want to have to do the, show the generic rectangle, you could get that by using the distributive property. And distributive property would say that, again, the number in front gets distributed to the terms inside parentheses. So 5 times 600, again, would give us the 3,000 over a bit. Okay. Then the 5 times the 20, distributing it to that term, would give us the 100. And then lastly, the 5 times the 8 would give us the 40. So what the distributive property does is tells us that we can and should distribute that number in front to all the terms inside. All right. And of course, then we can get our final product from that. 3,000 plus 100 plus 40 is 3,140. Now you might say to yourself, well, why do we need to show the distributive property if we know we can get that same result with the generic rectangle? And the reason why we're not so concerned about whether we can do it with generic rectangle versus distributive property is it's not about the solution so much as it is about a process. Once we understand the process of the distributive property, it's something we end up using, in algebra and many other situations. And so we need to sort of understand how the process works, and the generic rectangle is a means to understand it. So if we were looking at something then like B, we'd make it 10 plus 2 times 30 plus 4, or to make it a little bit easier with distributive property, we could just make it 12 times 30 plus 4. And for C, 7 times 100 plus 30 plus 4. All right. Now, if I was not going to do the generic rectangle for C, let's say I was just going to do it with distributive property, the idea here would be that I would break the 134 into 100 plus 30 plus 4. And then I would say to myself, all right, what are the results of that? Well, 7 being distributed to 100 would be 700. And then 7 being multiplied by the 30 would be 210. And then 7 being multiplied by the 4 would be 28. So if they asked you to rewrite this with the distributive property, that is what we'd be looking for. What do we get when we take 7 times 100? 700. 7 times 30, 210. 7 times 4, I'm sorry, I said that incorrectly. 7 times 4 is 28. 7 times 4 is 28. So that's what we would get for those different sections. And then, of course, the result would be adding them up, which again, we can do. But as I stated before, it's really not so much about the results. So 700 plus 210 plus 28 would be 938, it looks like. But again, it's less about the product and more about the process. All right, so the idea here for 282 is that they do want you to do that. They want you to go ahead and do the distributive property to find the results and try to do it without drawing the rectangles. All right, so let me just go ahead and again do one for you. Let's look at part B. If we have 11 times 2 plus 5, we're just going to make it into 11 times 2, which you can show that you're taking 11 times 2, or you can write the result. I'm okay with it either way. But 11 times 2 is 22. And then you're going to take the 11 times 5, which is 55. And then you're going to get your result. So it looks like 77. Again, you might say to yourself, well, it's easier to get the 77 by taking 2 plus 5, which is 7, times 11 is 77. But again, the idea here is that we're looking for understanding the process because of the mathematics that's coming down the road. For C, you'd break that into 4 times 500 plus 10 plus 2, which would give you 4 times 500. Well, 4 times 5 is 20, adding the 2 zeros, 2,000. 4 times 10 is 40. 4 times 2 is 8. So this is one where probably is easier to do it with distributive property to get that final product. But again, not so much about the product as the process. Okay. So we are going to have a second video for you on the homework.